Somewhere in Finland, an almost invisible film, dyed with the violet drained from an onion shell, protects a solar cell from the same sun that feeds its energy. It is not a trick of modern alchemy or laboratory eccentricity. It's applied science, sustainability, and perhaps the future of photovoltaic technology. If you're interested in science and sustainability, don't forget to subscribe to our channel and like this video, so you can be aware of more innovations that are changing the world. Your support is very important to us. The outer layers of a red onion, those that end up in the composting bucket or in the bottom of the trash can, are made of something more than cellulose and pigments. They contain anthocyanins, compounds with a natural affinity for ultraviolet light, and that, precisely, is what has caught the attention of a group of European researchers determined to change how we protect our solar panels. The research, published in ACS Applied Optical Materials and led by scientists from the universities of Turku and Aalto, Finland, together with Wageningen, Netherlands, has for the first time compared 4 solar filters made from bio-based materials. One of them, made from nanocellulose dyed with red onion skin extract, exceeded even the commercial standard based on PET plastic. This filter blocked 99.9% of ultraviolet radiation below 400 nanometers, a figure that left behind industrial filters made of petroleum derivatives. But the real surprise was that, at the same time, it allowed more than 80% of visible and infrared light to pass unobstructed. Scientists do not hide it. This finding is not only technical, it is symbolic. Transforming vegetable waste into high-tech solutions has a powerful cultural burden. Onion, omnipresent in the kitchen, becomes here the unexpected heroine of a battle against the obsolescence of clean energy. The film with onion extract is not only efficient, but behaves in a stable way over time. Its tone is prudent, as it corresponds to the one who has tested its invention in one of the most hostile environments for materials. A solar cell sensitized with dyes, extremely vulnerable to ultraviolet light. DSSC technology, although less well-known than traditional silicon, is popular in laboratories for its low light efficiency and adaptable aesthetics. But it's also fragile. Without protection, it can begin to degrade in just 2 days. Therefore, the success of the plant filter is no less. The other tested materials offered acceptable results in the short term, but weakened over time. Iron showed a good initial transmittance that declined with accelerated aging. Lignin, although effective, dyes the filters of an opaque brown that prevents the passage of visible light. The onion extract makes the difference. It not only absorbs ultraviolet, but does so without clouding the passage of youthful light. Here is presented an invisible shield that takes care of the cell without asking for anything in return. The manufacturing process is simple and biodegradable. The implications of this work go beyond domestic solar panels. These films could also be applied in emerging technologies such as perovskite cells or in biodegradable electronic devices. A universe of applications where the natural is not at odds with the functional. In the end, what this research proposes is not only a technical improvement, but a change of perspective. Today's science looks for materials that work well and disappear without noise, like onion skin, which fulfills its mission and dissolves with elegance.